How are you doing there, Jay? I nearly thought something was wrong because I hadn't heard from you, so I wasn't sure whether you were joining or not.
Oh,
Uh,
did I not text
you-
back?
no, 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 no. I
Oh, I
didn't
thought I
uh,
did.
not to click this, and I will move on to. Let me share my screen.
I had that maths test as well, and it went pretty well, to be fair.
Oh, good.
I
Yes,
think
I
I
was
was
going to ask.
confident.
Yes, very good. What did you get for that one?
I haven't got it back yet. I only did it on Friday
But you
or
gauged that it
yesterday.
was it was it was good.
Yeah, I think it went pretty well. Yeah, the test wasn't that hard, so it was
Good, good. And
okay.
that was on upper and lower bounds, wasn't it?
Yeah, it was a bit of volume, upper and lower
Yes, of
bound, and
course, and
then
surface area.
yeah, and surface area. And then do you know how it was a 40-mark test, and the 30 marks was on that, and then the last 10 marks was on a topic that we'd done before, which was just graphs and gradients.
Oh, so that wasn't too bad, I bet.
Yeah, it wasn't too bad, and I think I got that as well. Yeah.
Good, well done, well done. And any other upcoming ones that you've been made aware of?
Not yet, but we should be having a physics test soon on waves,
Okay, okay,
and
we can go
and
through
also
that in. Uh-huh.
yeah, and waves, and then in biology should be homeostasis that will be coming up. I'm not sure if it's after half term,
Okay.
but it may be after. Sorry.
So worth
Yes.
going through that at some stage in one of these
Yeah,
sessions,
of course. Yeah.
just to make sure we brush up and you're giving enough practice questions as well. No
Yeah.
problem. We'll do that, Jay. Yeah, thanks for letting me know. Okay, great stuff.
Cheers.
So we were looking at, I think we're on the very last question, number 21, weren't we?
Yeah.
On the
Yeah.
maths one. Yeah. So with this one, Jay, do you want to have a go
Yeah.
and see what direction you take with that one?
is
Okay, so you
K?
got AP equals AO, yes, plus OM plus MB. Come on, AO plus OM plus MB plus BP. Yes, you can definitely go that way. Definitely without a doubt. Now you have AP. Okay. Now the one thing you could do as well, Jay, you know that AB is B minus A or minus A plus B.
Yeah.
And you've told that AP is a certain fraction, K, in AB.
Yeah.
So you can write that AP in terms of B minus A
B
with that K
minus.
in front.
Oh, so this came in front of there.
So in this, on the last line you've got down there, yeah, that is AB, isn't it?
Yeah,
If
AB.
you look
Yeah.
at the question, it says that AP is K times AB.
Oh, okay.
Look at the
Oh, I
question.
know. Yeah.
So you can then write AP as being equal to K times AB. Now you know that AB is B minus A because you've established that. So it's
Yeah.
K times of B minus A. Does that make sense?
So K times. Yeah, so I'd put the K there.
Yeah, but that would now make it AP. And if you put the K in front of AB, you also need to put the K in front of everything that's on the right-hand side because it's an equation, remember?
Okay, yeah.
So whatever you do on the left-hand side, you have to do on the right-hand side as well.
Okay.
KAB, yes, correct.
Is equal to K minus A.
So you'd have to put that in brackets, wouldn't you?
Yeah.
Minus A plus B to show that I'm also timesing. Okay, now that is equal to AP because it says AP is K times AB. Can you see that?
Yeah, yeah. So I could put this. No, actually. So could I put another equals?
Equals,
Saying,
correct.
then would I just write this bit there?
Equals, yes, absolutely correct.
Okay. Right, and then
Now you might have to form some other equations as well.
okay.
So can you see any other equation that you can formulate? Now you've been told that MPN is a straight line.
Yeah.
Yeah, now that could be useful information. How might you use that? Any idea?
Um.
How do I move it?
Well, it says to use the MPN, so I'm trying
Yeah,
to think how you'd use that. So Well, could you say AP is equal to AN plus NP?
AN plus NP,
Yeah,
correct?
because the AN is 2OA.
Correct.
So A is equal to AN plus NP.
Yeah.
So could we say that's 2A?
So AP, so you say AP equals to AN plus NP, and AP, N is 2A, correct? Plus NP, yeah, so what could NP then be? So you already know what AP is, isn't it?
Yeah.
We've
And
got
then,
an expression for AP on your third line from the bottom.
oh yeah, yeah.
That is also AP. Can you see the one with the K, the one that's got KAB? That is AP
Yeah, so could I write this and then that's equal to 2A?
plus NP.
Yeah.
Yeah.
And then I'd say that's equal to 2A plus NP.
Yeah.
Okay. And then we'd have to form the AB one now.
Yeah.
Maybe.
Yeah, we've
So
got home in AB1 because you want to try and eliminate. Yes, that's a good point. But you've already got the AB1, haven't you?
yeah, I've got it as AB is equal to minus A plus B.
Yeah.
Minus A plus B and then which is equal to 2A plus NB.
So you've got AB equals minus A plus B equals 2A plus NB. So there'd be a way to eliminate, is a question that we're going to ask here. So it might be easier if I try and share my board. New share. So if I just sketch this out. Not quite representative. Let me rub this off. So it's something more like here. It's twice, isn't it? More like that.
Yeah.
Okay, and we know that's a midpoint. And we're told that this here is a straight line, MPN. And we're given A, and that's our O, that's our B.
Yeah.
And we're told that this is A. We're told that this is 2A. We're told that OB is B. So we know that OM is B over 2, so on and so forth. So what you looked at, the path you looked at to start off with, you looked at this path, I think.
Yeah, OA to OM to MB to
OA
AP.
to AP to, yeah. So if I just write what you've got so far, you've got that AB, this is B minus A.
Yeah,
Yeah.
yeah, that's it, yeah.
Okay,
Mhm.
which is this part here. And we
Yeah,
know
yeah.
therefore that AP, we're told, is a certain fraction of AB. So therefore this is the same as K times B minus A. Yeah?
Yeah, yeah.
Okay. Now the next thing we've also been told is that MPN, so MPN is a straight line. Therefore we know, okay, if you look at it, you can say MP plus PN gives you MPN.
MP, yeah, yeah.
Yeah, okay. Furthermore, if we look at MP, there's a way of expressing MP, and there's also
Could you say that
expressing, yeah,
MP is equal to MO
yeah,
with plus OA plus AP,
correct.
and then that is, in other words, that is MP is equal to MO, which is minus B.
Nearly there, over 2.
Oh, sorry, minus B over 2, yeah.
Good.
And then plus A, sorry, it's plus positive
Yeah,
A.
good.
And then plus our AP, which is
Which is this thing here, isn't it?
yeah, which is that, yeah, K in
Okay.
brackets B minus A.
Good. This is MP.
Yeah, and then would you work out your MN?
Well, wouldn't we want to work out, we could also work out our PN if we wanted to.
Oh yeah, PN.
Because in our expression, remember, we've now got an expression for MP, and now we need an expression for
PN.
PN.
Yeah. So for PN, it
Yeah.
would be PA. So PN is equal to PA.
So PA
And then plus 2A.
plus 2A. Okay. Now
Yeah.
PA, we know is the opposite of AP,
Yeah.
isn't it?
Yeah. So would that be minus KB
Good.
minus A?
Yeah, absolutely. Plus 2A. Because remember,
Oh yeah.
yeah, because it's PA plus 2A.
Yeah.
So now I get, what do I get? I get, I can simplify this a little bit more. And this will give me,
Wait, so why have you done the extra plus 2A? I don't get that bit.
because PN is the same as going PA
Yeah.
and then going to AN.
Yeah.
So
Okay.
PA is moving opposite to AP. So we minus this.
Yeah, and then that 2A is AN.
Okay. So this here, this part here is PA.
Yeah, that's PA. And then the second bit is just your AN.
Good. And this is your AN. Good.
Okay, that makes sense, yeah.
Yeah. Okay. Now we go back to this, so we can simplify this a little bit. And if we want to simplify this, what did this become? Well, we can group the like terms together.
Yeah.
So we can have something like minus bk minus or plus, because a minus and a minus.
Yeah, so plus
Plus.
8.
Correct.
And then plus 2a.
So I can rewrite this in a certain form that's maybe a little bit better to use or more useful. And I can say a and write 1 plus, sorry, k plus 2 minus bk. Yeah?
Yeah, yeah.
You happy with that? Okay, good. Now I know, again, just as I've done this Pn, I can do the same with the top here, just to make it a little bit easier to work with. So I'll group the like terms. So I'm going to get minus b over 2 plus kb. Yeah.
Yeah.
And then plus a minus ak.
Yeah.
Yeah.
Yeah, because the minus a times the k.
Good. So if I simplify this, this will look something like b 1 minus, sorry, is it? Yeah, if I take out the b, so I've got k minus a half.
Yeah, k minus a half, yeah.
Plus a, which is now 1 minus k.
Yeah, yes, you just factorized.
Yeah, you happy with that?
Yeah, yeah.
Okay. So this is our expression for MP. Now we know that in the we know that MP and PN are in what? Are in the same direction, isn't it?
Yeah, yeah.
Yeah. So they've got the same direction. So in other words, the coefficients, this coefficient in here with the B must be equal to the coefficient there as well. Likewise, the coefficient in the A, if they're in the same direction, must be the same, but over a certain fraction. Yeah, if that makes sense.
Okay.
So MP is a certain fraction of PN.
Yeah, yeah.
Yeah. So let's see here. So we can now write an expression for MN, can't we?
Yeah, we could say that.
We could. Sorry for yeah. So MPN is the same as MN. This here is the same as MN. Are you happy?
Yeah, yeah. Because it's just straight from M to N.
Because the two P's cancel out.
Yeah, yeah.
Straight is just going to MN.
Yeah.
Yeah. So now I can say here that my MN. So my MN would be equivalent to adding MP plus PN. Now I know MP is this thing here.
Yeah, so B.
And I know PN is that thing there, isn't it?
Yeah, so you just add those two.
Yeah, so I can add those two. You're absolutely right. So it's B K minus a half. And then I'm going to add it to this B here.
Yeah.
Minus BK. And then the A's, I can deal with the A's now, which is A, 1 minus K. And it's going to add to this plus A, K plus 2. Yeah, so I've added this here, A1 minus K, with this here. And then I've added the BK minus half with this minus BK.
Yeah, yeah.
Yeah, okay. So I'll have a go at simplifying though. What would that give us if we simplify that?
So equal to so it would be BK minus BK, which is going to cancel out.
Good, yeah. So there's going to be a BK and a BK that's going to cancel out from here.
It's going to be a B of minus half B.
So you remain with minus B over 2.
Yeah, or minus B over 2.
Isn't it? Because that cancels off with that one. So the B times the minus half, you remain with minus B over 2. Good.
And then
what's the next part going to be?
Minus, okay, so then the same thing would be minus AK plus AK, which is going to cancel off. So you're going to be left with minus.
So here I've got, you're right, for A there, gives me A. That minus AK and the plus AK will cancel, but I'm going to have A, won't I?
Yeah, so it'll be 1A plus 2.
A. Yeah.
Yeah, so 2A. And then.
So,
wait, so that'll be 3A.
3A, good, yeah.
Yeah.
So this looks something like 3A minus B over 2.
Yeah, yeah.
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 So that's MN. Okay.
Minus B over 2. Yeah.
Yeah, we're happy.
Yeah. And then
what do we do next?
Now you know the MN.
And know that MP is a certain fraction, isn't it? So if we know MN, we know MN. Yeah. We know that MP will be a certain fraction of that
M.
direction.
Yeah.
Yeah, because it's a straight line. So it will be a certain fraction. And if I look at MP, my final expression for MP here was, where is that? This was the final expression here, isn't it?
That blue thing, yeah, the blue.
Yeah.
So then would you put, right, so if I write that down.
Yeah.
So if our MP is equal to B K minus 1/2 plus A 1 minus K. Yeah. And then would you sort of make a comparison between these?
Yeah, okay. So if we make a comparison, what would that give us then?
Okay. So, well, we got a minus B and 2, they're the same.
Okay.
And then, one sec.
All right.
So we got a minus B over 2, they're the same. And then we
Okay, so MP, yeah, on A, okay, plus KB minus A, okay.
So this is the same, and that's divided by 3, but then we've got this extra.
Yeah, how might we deal with that then?
Okay. Do you know before we like factorize and like simplified the mn,
Yeah,
could we go back to that stage and then cross off things to?
yeah, you could actually. And the way you could almost think about, you can either think in terms of MP. So you say
Yeah.
MP is a certain fraction of MN, or you could also think in terms of PN. So PN is also a certain fraction,
Oh,
yeah,
mp. Yeah.
yeah, of MN
Oh, sorry, mn. Yeah, yeah.
or NM, whichever way you look at it, if you're going from N to P.
Yeah, yeah. Okay.
Yeah.
And then we had a mp formula.
Yeah.
1 minus k. And then we see that
Yeah.
this and this are the same,
Yeah.
and then a1 minus k and this are the same. So the only difference is minus bk plus a in brackets k plus 2.
Yeah.
So that therefore that means that our pn, but we already know what pn.
So is there a way of finding what the value of K is?
Um, with the k.
Just one moment, Jay. 1 minute long. I
Yeah,
just gotta go and open for somebody. I think I just heard a
yeah,
knock.
no worries, sorry.
1 minute, sorry. Um,
I was thinking
Yeah.
now, could we,
Yeah.
because we know more things about different things, could we write our AP thing now, our AP equation now, and then compare it to AB?
Yeah, you could do that as well, yeah. So,
Mm. And then if we wrote our plus B, and then actually, I'm not sure if that would make a difference. I don't really think that actually makes a difference. The AP.
what you've got there. There's something else to be done because you've decided you've decided to go to the top, Jay, to the top line. Are you trying to find? Sorry, where's my pen? So Mn, if this is
Yeah.
MP, yeah,
Mhm. Yeah.
MP over Pn,
PN. Yeah. MP, PN.
or rather, I'll do it this way: MP
Yeah.
over Mn, yeah,
Yeah.
that here, this ratio of MP over Mn can also be expressed as another ratio in terms of Pn to Nm. So what I'm trying to say here, Jay, is if we look at ON,
Yeah.
the other line ON, there's a ratio of, let me just take this off. Let me take this off. Razor, oh, come on. Oh, good. So here, if I've got a ratio of OA to ON,
Yeah.
that ratio you can see is OA to ON. What would be that ratio?
The ratio would be A
Over
over 2A.
Not quite. OA over ON.
Yeah, over ON, yeah. Which is, wouldn't that be 3A?
Correct. So it'll be A over 3A, isn't it?
Yeah.
So that ratio will be
1 to,
1
oh
over
yeah,
3.
1 to 3.
Third.
Yeah, 1/3.
Okay.
Yeah.
Now, by the same token, now, if I had to ask you what AN as a ratio to ON, what would that be?
So AN to ratio of ON. Okay, so AN, that would be 2A, so 2A to 3A, so it'd be 2/3.
2/3. Okay.
Yeah.
Now, there's one way I could have found this ON ratio, and that is by saying 1 minus 1/3. And that would have given me the ratio of AN over ON. You happy?
Yeah.
Because essentially, I am taking away 3A from this thing here, which gives me this 2A over 3A. Yeah?
Yeah, okay.
You happy with that? Good. So by that same token now, 1 minus AN over ON is the same as OA over ON. Yeah?
Yeah.
You with me so far? Good.
Yeah.
So if I use the same logic over here, and I say, well, MP over MN will be a certain ratio. And this ratio will be the same as, if you like, it will be the same as, so like this one here, OA over ON is also the same as what I'm trying to say. Let me just use here so then I can bring it directly down here. This OA is the same as ON minus NA.
Minus. Yeah. Oh yeah, I get that. Yeah.
ON subtract.
Minus.
Yes?
Yeah, that is OA.
And therefore, this all over ON is the same. These ratios are the same. Yeah?
Yeah.
So I can do the same. And I'm going to say MP over MN. This is the same as, what is this the same as? This is the same
as MN minus
NP.
Yeah, minus NP, yeah.
Over MN. Yep.
Yeah.
So now, I already know what my, almost a bit like forming two equations. I already know what my MP is, don't I? I think I established it here.
Yeah, it is BK minus a half. Yeah, that one.
Okay, good. And that one over MN.
Which you established as well as 3A minus B divided by 2.
Good, okay.
Yeah.
And these are directions that are going in the same line, so I can find them as ratios. It's a little bit easier, okay? So if I look at my MP, which is BK minus a half plus A, 1 minus K, okay? Now this is my MP, yeah, over MN. Now MN is, what's MN? Where's MN?
MN is your bottom
minus
3A.
B over 2.
Yeah.
This one here, isn't it?
MN yeah, it's that one there, here. Plus 3A.
Okay, plus 3A.
Yeah.
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 So the directions would have to cancel, just as in here. So they're going to have the same directions. So if I look at this is a certain fraction in the B direction, certain fraction in the A direction. Likewise with this. Yeah?
Yeah.
Now this here is also going to be equal to. Now, do I have an expression for Mn minus Np? You following me so far, Jay?
Yeah.
Yes. Okay, good.
Mn plus minus Np. Well, Mn minus Np, that would be Np.
Yeah, which we have.
Yeah.
So whatever
Yeah.
it is that we get, but I can get, if I know Np, which is this thing here.
Oh yeah, yeah. Np, yeah. Np. And then would you do Mn minus that?
It'll be negated, correct? Okay.
Yeah.
So they'll be negated. Now, there's a bit of an easier way as well that we could try and look at it. If we look at the direction, or if we look at the coefficients of B in MP, so these coefficients of, where is it, MP, the coefficients of B.
Yeah.
And the coefficient of A is 1 minus K for MP. This here is a certain ratio. So this ratio of MP, the B's, the ratio that the B's are in to Mn, which is here, this ratio must also be equal to the ratio of the A's. So if I think about it to say K minus a half, all right,
Yeah.
over the coefficient of B here is minus a half. This here must also be the same as the coefficient of 1 minus K over this coefficient of 3.
Yeah.
Yeah?
Yeah.
And keeping to ratios. So that's one way you can also go about it. So now if I do the maths here, what do I get? I get 3K, and I get minus 3 over 2. And I get, what do I get here? Minus a half.
Yeah.
I'm cross multiplying, plus a half K. Yeah?
Yeah.
Now I can group all the like terms together. So 3K minus a half K gives me what?
And that would be 2 halves K.
2.5 K.
And then
And then if I group the numbers together, I've got minus 3 over 2, which goes to the other side, become plus 3 over 2 minus a half.
That would be that would be plus 2 over 2. So 2 over 2.
Yeah,
I think.
1.5, 2 over 2, which is 1.
Yeah, which is 1.
Yeah,
Yeah, so
good.
2.
Now from here, you can see that 2.5 K equals 1. So this is the same as 2 times 2 plus 1, which is 5 over 2. K equals 1. And now I get my K as being equal to 2 over 5.
Like,
Yeah?
how did you go from the 2.5 to 5 over 2?
No problem. So I multiplied 2 times 2.
Oh wait, you just you put it as a upper.
Yeah.
Actually,
And then I divided to find what
yeah,
my
yeah, that makes sense. I just
okay?
didn't see. Yeah, yeah.
No problem. Now the biggest logic here where students find it very, very hard to make the connection. I was hoping, and this is why I was using these ratios to try and show you the connection, is that because these are in a straight line, these are on the same line.
Yeah.
The ratio of the coefficient of the B, so if you see what we've done, what was that? Oh, we're cross multiplying here. If I look at the B coefficient on Mn,
Yeah.
the B coefficient is minus a half.
Yeah.
Yeah. Now, if I look at MP, was it MP we're looking at? Yeah, MP. Now, where's the final? The coefficient is K minus a half.
Yeah.
That's the coefficient of B, because K is a number. Yeah?
Yeah, yeah.
So this ratio of K minus a half to the coefficient in Mn, which is minus a half, this must be the same if they're on the same line as the coefficient of the A, which is 1 minus k. Again, it goes to the top. Can you see? The k minus a half from that expression is at the top. And it's compared to the coefficient of B in Mn, which is minus a half, which is that minus half.
Yeah.
Yeah? Likewise, now for the A, the coefficient, I bring it to the top. That must be equal to the ratio of the 1 minus k against the A to the ratio of the coefficient of A in Mn. So that is my 3 there.
Yeah.
Okay? And then the rest of it now is just cross multiplying and solving the equation. But the hardest step to remember is to try and equate the ratios of my line here. So in other words, I'm just going to write it. MP can be written as lambda some fraction of A plus we're going to say let's use another symbol, beta or Z. Or maybe, yeah, we'll say Z. Z times of B. And I'm just going to use here X as well. X times of A plus Z times of B. Okay.
Yeah.
Now, if Mn is Y times of A and we'll say W times of B, if this is on the same straight line, then what I'm saying is that the ratio of the portions of this line, which is in the X direction, X over Y must be equal to Z over W.
Yeah.
And that is exactly what we did here. We looked at the coefficients of Mn, the A coefficients and the B coefficients, wrote them as a ratio of MP. And we wrote the corresponding ratios. So the coefficients of B, please note, are minus a half. And in this one for Mn, the coefficients of B is minus a half. So that's the ratio there.
Yeah, okay.
X over Y. That must be equal to the coefficients of A, the coefficients of A here over the coefficients of A in Mn, which is this 1 minus k over 3. They must be the same, which is that Z over W.
Yeah, kind of.
Or X over Y, I beg your pardon. That's the X over Y because those are the coefficients of A. Yeah?
Yeah.
The coefficients of A in this portion of MP compared to the coefficients of A in the overall line must be equal to the coefficients of B in this portion of line compared to the coefficients of B in the overall line. That's the other way to say that. That's what I'm trying to say in another way.
Okay.
Okay. So I think that was the part that you struggled to make the connection, but it's normal. It is a bit of a tricky connection to make, but you would have gotten at least 3, if not 4 marks for working out Mn and all that. And just to be precise, you'd have gotten 4 marks, Jay.
Yeah, okay.
Just the last part that you'd have lost a mark for not making that final connection.
Yeah, okay.
Okay. So if you want to, just as a way to help you assimilate things in your own time, you can obviously take a picture of this.
Yeah, that'll probably help.
And look at the question again, and then just try and follow through the working to see if you can spot the pattern. So k equals 2 over 5 is your final answer. I mean, there's a lot written down here, so it might be very hard to see. Okay. So we might even take out some of the stuff that might confuse you. So if we take this off, and I'll write a few things here to say equate coefficients. Equate coefficients as ratios. Ratios of respective directions. Okay. So
Yeah.
in other words, this top line here at the top represents, this represents MP. This top line here.
Yeah.
And the bottom line here represents MN. Okay.
Yeah.
This is, it's not very clear. This here is MN at the bottom.
Yeah. Yeah.
All right.
Okay.
And that's MP. So now you've equated the B's to the half, the 1 minus K to the 3. That's what I mean. Are you
Yeah.
clear with that, Jay? Is that fairly clear?
Yeah. Yeah. That makes sense. So the MP is the top, and then the MN is
Correct.
the bottom. Yeah.
Correct. Okay.
Got a picture.
Cool. Nice one. That was a tough one. And maybe a good time to take a bit of a breather.
Yeah. All right.
And we'll resume soon after. So it's
Okay.
now 16:02. How long do you want the break for? 3-5 minutes, up to you, Jay?
Yeah. 3 5 minutes. That's good. Yeah.
Okay, let's go for 5 then. So I'll see you at 16:07, yeah?
Okay. All right. Cheers.
Nice, and see you soon.
Okay. See you.
Cool. So another way,
Yeah.
Jay, I just thought to say maybe another way of helping you visualize the problem also. If you're
Yeah.
facing respective problems, is you can do that? Yeah, we can. If you have a graph,
Yeah.
I'll just move this to the side a little bit and minimize it. Okay, so if we have a graph, like so. And let's just imagine, I'm just going to make this basic just for the purposes of understanding. Okay. And let's just imagine we have now I'm using X and Y coordinates. Okay. Let's imagine there's another point. I don't know, some point. Now, what are we going to call this? 3, 4, 5. So that's 6. And let's call this, hang on, so 3, 4, and we're going to call this 8. So this is 8 to there, and to there it's 6. Okay.
Yeah.
So that's my line there. Now, if I take a point on this line, and I'm just going to choose an arbitrary point, just for example, halfway perhaps, just for illustration purposes. And I tell you that this is 4 here. Yeah.
Yeah.
What do you say that coordinate? If this line, if this point is on the line, what do you say that coordinate would be?
Well, if it's 8 divided by 4, that's 2. So then would you 6 divided by 2, which is 3? So it'd be 3.
So this point here would be 3. Okay, good. So you've used ratios. Okay. So what I'm saying here, Jay, which is what I was doing with the other problem,
same.
The ratio of this x direction of this distance to this over a distance here. Yeah. So that was like me comparing the coefficient of the b's. So the ratio of this must be the same as the ratio of this guy over this guy.
Yeah, yeah.
Okay. That is why in the previous problem, note that I equated, this can go back. Yeah. I equated the ratios of the b. So k minus half over 2 must be equal to the a direction. That's not like comparing the a's. The ratio must be equal to, that's why I had my equal to sign, of the coefficient of a, which is 1 minus k in my short line, which is MP, to the ratio of that a in the long line. All right?
Yeah.
Which is what we're doing here. So as you've rightly said, you've said 4 over 8 must be equal to whatever this thing is, x over 6. Yeah? And that is how you found to say this would be a 3. So it's the same logic we're applying.
Yeah.
Does that make sense?
Yeah.
That's why I'm comparing the ratios, just so you know it's where it's coming from. So if you can understand it from here, it's the same understanding to why I was equating them in the previous question. All right.
Yeah. Okay.
All right. So you're happy with that?
Yeah. Yeah.
Good, because these can be pretty tricky, especially the last stage. Like I say, that's the hardest stage for a lot of students to make the connection. But it's not so different to if you were given a straight line equation and had to find a coordinate. All right.
Yeah.
Okay, cool. Nice one. So the next, if I open this, the next one is Maths Check 2, which has got a slightly different array of problems. If I share this, Maths Check 2, here we go. And hopefully should be able to see this. Now, did I send this through to you already? Perhaps.
Is it? Do you know what it's called? The file
Maths check 2.
maths check 2. Okay.
Yeah.
I've got maths check 1.
Okay.
No, I've only got maths check 1 here. That's it.
Okay, cool. No problem. So I'll commence to send that through the chat.
Okay.
Computer. Jay. Yeah, that's you. Okay, so that's gone through, Jay.
Oh yeah. Okay. Thanks.
Okay.
Yeah, I've got that open here.
Okay, good.
And is it just the first question?
Yeah, we can start off with the first, and there's a little bit of a warm up after doing that hard paper.
Yeah. Yeah.
Easier.
Okay.
Yeah.
So, okay. Yeah. So 1.5.
Yeah, good.
Okay. Two. Plus 5. Sounds. Her percentage profit is 6.4%.
Well done. No problem. Good.
It says has me walks around in a circle. We're down to 80 meters, or 8 points equal.
Yep, good.
Thanks. Well, that depends though, because do you know how 4 of the points are moved? They
Mhm.
could have been moved at different distances to the original point, if you know what I
Right.
mean.
Mhm.
But they haven't stated that, so how would you?
Well, if you had to, so what was her average distance you moved between one point and the next point in the first?
It was 31.42 meters.
Okay. So if you were given these points and you were asked to find the average that she's traveled between the points, what answer would you get? Or how would you do it? Let's ask ourselves that question. How
So,
do you
sorry,
find the average distance traveled between each point?
for the second, for part B, the
Yeah.
circle for that. So would you, if you wanted to look at the average, you would well, the points from A to B and from C to D and from E to F and from G to H are the same.
Mhm.
And then the points from H to A, B to C, D to E, and F to G are the same. So could you label them also as like X and then 3X?
Okay, let's imagine I just told you a statement like I traveled 100 meters and I
Yeah,
traveled through 5 points to cover that 100 meters. What was my average distance I covered between the points? How would
it
you
would
do?
be 20.
It would be 20. Would you need to know
Yeah.
how spaced the points were?
No, no.
So now I'm going to ask the same question. If
Oh,
you wanted to find the averages traveled, would you need to know
oh,
the distances that they've been moved?
no, you wouldn't. No, it would be the same. It would be the same thing because the average would be as if they were equally spaced out. So
Exactly. That's what the
yeah,
average is. Correct. Correct. So it wouldn't be any different. You're right.
yeah. Oh, that makes sense. Yeah.
Yep. Good.
Um, mean distance would not change because could I say, as to explain it, because there are the same number of points and it is the same total distance around the circle?
Correct, correct, correct.
Okay.
Okay, good.
And then on to 4. There are only blue cubes, yellow cubes, and green cubes in my. There are twice as many blue cubes as yellow cubes, and 4 blue. Twice as many blue cubes as yellow cubes. Would it be 0.09?
0.09. What you get as a fraction if you expressed it as a fraction?
1/11.
1/11. Yeah, correct. Yep, well done.
Would you express it as a fraction instead?
Even that would be fine. It's just I didn't see you working.
Oh.
So, sure.
Oh, sorry.
Yeah, no worries, no worries. Yeah, you've done the right thing. Yeah, absolutely. Either one would give you the mark. Okay, good.
Yeah.
Well done. Now, the next part, you'd need the graph. So you can do this once you've printed it out
Okay.
as a homework assignment, okay?
Yeah,
Now we can
fine.
move on to number 6.
And 6.
Good. Yep, no problems.
Mm.
If you just scroll a little bit further down, Jay.
Sorry.
Okay.
does that prove?
You've kind of put your own numbers in there, but you've made it very specific because you've said let A be 2 and B equals to 3. Is there any specific reason why you chose for A to be 2 and B to be 3?
I just did the smallest number, so there was less chance of mistakes when I was doing my zeros.
Okay, well, you could have made A then 1 and B equals to 2, I suppose.
Yeah,
But,
I could have done that as well, yeah.
Yeah, you could have done that, but I think none of those would have been the best route forward because then you're specifying your case for a particular value of N, B. So just to take you through that one, hopefully you can see my whole screen, yeah?
Once I'm just gonna go back onto
No problem.
Yeah.
Okay, good. So you've got 100A times 1000B,
Yeah.
okay? Can be written now, let me just look. Can be written in the form of equals to, bring this, equals to 10 to the power of W. You happy with that?
Yeah.
Okay. Now it says, the next line, that show that W is equal to 2A plus 3B. This W will be equal to 2A plus 3B. Okay. Now the 100, how else can I express 100 in terms of powers?
You could say 10 to the power of 2.
Correct. So that is the same as 10 to the power of 2, because that's 100, to the power of A.
Yeah.
Yeah. Times
10 to the power of 3 to the power
10
of B.
to the power of 3. Correct. Which is equal to 10 to the power of W. Okay.
Yeah.
Now here I've got to use laws of indices, isn't it? Now,
Yes.
laws of indices states that if I've got something that is A to the X
It times
A to the Y, my result is the same as what?
It's adding the 2A plus the 3B, plus the 3B.
Okay, well done. So you're right.
And that proves it.
This here is 2 times A, that's 3 times B. So I can rewrite this as 10 to the power of 2A times 10 to the power of 3B is equal to 10 to the power of W.
And then therefore
indices, using that law, and this is the same as 10 to the power of 2A plus 3B. This must be equal to 10 to the power of W. Now, if these are the same, that means their indices also must be same. So 2A plus 3B must be equal to W if these are the same.
Yeah, that's a better way,
Okay? No problem.
Would you still get marks for?
No, you wouldn't, unfortunately.
Okay.
Because they would want it in a generalized form. What they would want you to demonstrate is applying laws of indices. So that's where the marks are coming from. So can you apply these laws of indices? Okay.
Okay.
But you've seen it, so you know next time what would be expected of you.
Yeah.
We can move on to the next set of questions. Number 7. How many marks is this? 5 marks.
So ABC is pleasing what that's on C, D, C, D, A. Okay. Okay, and I got an answer of 28.5 centimeters squared.
Yeah, so just talk me through what you done, because I thought I was following and then I got lost after a bit of
Oh, okay. So I just worked out the area of the trapezium
yeah,
and got 102.
yeah.
And then
I was
I
following that
did,
part.
yeah, and then I tried to work out the area of, do you know, the triangle on the left?
Yeah. Again, I'm
So,
following that part, so I understood that. Then you try to find the area of the rectangle, 10 times 6.
wait, I'm just trying to work out, I don't think I worked out the area of the triangle correct, because I did 7.5 times 6. So I didn't know I was meant to work out the bottom length first, the bottom of it.
7.5 times,
Times
yes, it's the
6.
bottom part that you need.
Yeah, that's not
Yeah,
correct,
you're
yeah.
absolutely right. The bottom
So
part, right, what
I
on?
did work out the bottom part to be 4.5. So if I do it again, it'd be 7.5 times by 4. No, sorry, 6 times 4.5,
Yeah,
and that is 27. And then 27 plus 60.
sorry, 27, aren't you meant to divide that by 2?
Yeah, yeah, it's 27 divided
It's
by
half
2.
base times height.
Yeah. Then you add 13.5 to 60. 73.5. And then I did 102. Then I'm going to do 102 minus 73.5.
Okay.
.5, and then 24 minus 14.5 is 9.5, and then so this is
Yeah.
28.5, and then wait, I'm trying to think. Well, could we, because it says the angle, could we just use sine and cosine and all that to work it
Yeah,
out?
yeah, that would have to come in surely, yeah.
Yeah, yeah. So the opposite and the adjacent. And then the angle is 32.3
Better, good, well done.
degrees.
Good man.
Okay.
Yep.
So is this the final answer?
Yeah, that is the final answer. Good, well done. Nice, good.
6.
Now let's think a little bit about that one, Jay.
Yeah.
Less cleaners. So is it going to take them more time to finish or less time?
Oh, it's gonna take them more time.
Hmm.
Is the answer 61s? Oh, how much are each? Wait, hang on. Done this one. 61 £61.50.
Not quite.
Ah,
Not quite. So you've said each cleaner is paid £8.20. So you found the 7.5. How did you work out that it takes 3 cleaners 7.5? How did you work?
so you could do it two ways. You can either do 5 divided by 3, which is, I think, 5 divided by 3. It's 1.666 recurring, and then you do that times by 4.5.
Okay, why did you times it by 4.5 when you had divided on the other side?
Because it's reverse, because it takes actually longer if there's less cleaner.
I understand. Okay. So if we try and use that same rationale, and I'm just going to bring my whiteboard.
Because couldn't you also do like what it takes us to get from 5 to 1, and then 4.5 times by 5, and then divide that answer by 3?
Okay, so let's ask ourselves, how long would it take one person to do the job then? If 5
Yeah,
cleaners take
okay.
4.5,
So
now how
if
long would it take one to do the job?
it would take 4.5 times by 5, which is 22.5 hours.
22.5 hours for one. Let's try and look at it slightly different here. So I'll give you another way to think about this. And if I'll just bring my board, we can have a look at it. Oh, there we go. Oh, so it's the next one down, isn't it? Number 9. Yep. Okay. So to view it differently, if I just start off with an example, if it, let's imagine it takes 5 people 1 day to dig 1 hole. Yeah.
Yeah.
So 5 people 1 day to dig 1 hole. How long would it take one person? How do you do this part?
Would you say it'd take 5 days?
You're right. Absolutely right. Okay.
To do 1 hole.
Yeah, one home by one person. Sorry, sorry, 5 days. I should have put 5 days here and
Yeah.
go there. Okay. So according to your theory, what you said was 5 divided by 1,
Yeah, 1 times 5.
5, and then 1 times 5. Okay. So if we
Yeah.
apply what you've just done then, so 5 cleaners, so it might work. Let's see what happens to it. Take 4.5 hours. Okay. So now we said therefore 3 cleaners will take how long? So you said 5
So
divided by 3, and then you times that to 4.5. Is that right?
yeah. Yeah, so times 4.5
Okay, good.
is 7.5
So you said 7.5
hours, yeah.
for each one. And then you said 7.5 times £8.20.
20, yeah.
Okay. Okay. And you get 61, is it?
Yeah, £61.50, yeah.
£61.50. Now let's just read the question. What does it say? So they paid 8. How much will each cleaner? So it's not the total amount that they get paid, but each cleaner. Okay. Now this is a problem of inverse proportionality. Okay, so things are not directly proportional, they're inversely proportional. As you reduce the number of workers, you increase the total number of hours, isn't it?
Yeah,
So if you
yeah.
look at the task itself, the easiest way to think about this is think about the task in terms of how much manpower does it require, this task
Okay.
itself. Okay? How much manpower does it require? I'm just thinking maybe there's an error where you've made because your method should vaguely work, I think. Well, it should. The manpower, but this is another way to think about it. So we're going to try it with this. If this doesn't work, then we're going to look at another way. We'll compare the answers, yeah? Just to see if we
Yeah.
get the same thing. So the manpower is 5 cleaners for 4.5 hours. So that gives you 22.5 cleaner hours. That's how much the job takes.
Yeah.
Remember, this is in number of cleaners, and this is hours. So when I times the 2, my unit would be cleaner hours. So the job itself requires 22.5 cleaner hours. Yeah.
Yeah, yeah.
Now, if I only have 1 cleaner, to find the number of hours, I'm going to have to take, well, this is how much it takes, the manpower, 22.5 cleaner hours, and I've only got 3 cleaners.
Yeah.
If I divide the cleaner by the cleaner, I remain with
Number
the
of hours.
okay. So what's 22.5 divided by 3?
7.5.
Okay. So we get 7.5.
Yeah.
So these are the number of hours I'm going to need, isn't it?
Yeah, which is the same.
Which is the same thing. So 7.5 times 8.2.
Yeah, yeah.
Yeah, and you get 61.50.
Yeah, same thing, yeah.
Yeah, so we have the same thing. So you're right. Okay. Now I'm just trying to think here whether there is, so each cleaner is paid for each hour. Now this is where it gets a bit tricky. I think this is where we've just got to be careful. It says each cleaner is paid £8.20 for each hour or part of an hour.
Oh. Oh, okay. So then it wouldn't be, it would be, you times it by 8.
We
£8
times
20.
it by 8, then don't we?
Yeah.
Yeah. So what does that give us?
7.5 times by 8 gives you 60.
Not quite though.
Sorry. Sorry. £8.20 times by 8 gives you £65.60.
Much better.
Yeah.
Yeah.
Okay, that makes sense. Yeah.
Yeah. So it's just there's a little bit of a catch there.
20 is equal to 65. Yeah. Okay.
Okay, good. Well done. But there was a catch there, and it's very easy to get caught by that.
Yeah, yeah.
This is each hour, all part of an hour they work. So they kind of threw in that at the very, very end. Okay, I'm just looking at the timing of things and which ones you can look at in your own time because they're graphical questions. Number 10 and number 11, because you need to get your protractor for that one.
Okay.
Yeah. Number 12 we can do. Yeah. But I'm just
Yeah.
looking at the time. So perhaps we'll try and complete the rest of the paper in the next upcoming section, but we're not too far anyway. And feel free, because at least this paper's got things like functions in it,
Oh yeah.
which
Okay.
I want us to attempt exam style questions.
Yeah.
Because we've not really done anything yet on functions, inequalities as well, which I also
Inequalities.
would like us to revisit, make sure you're okay. And then also, most importantly as well, I think this is quite handy to practice as often as possible, is exponentials.
Exponentials. Okay.
Yeah, so there's exponentials in there. And then there's angles in polygons, which is
Oh, yeah.
classic number 12. Yeah.
Yeah.
So I'd like us to revisit that because we didn't obviously go through that in the first paper. And then there's some
Yeah.
stuff on circles, which again, I'd like us to go through. Okay. Nice one, Jay. So we'll leave it at that. We're gonna go through 23. No, we've not done sequences, so we will skip 23. No problem.
Yeah.
Good stuff. So I'll
Yeah.
see you tomorrow. What time would you like to start tomorrow?
I don't mind, to be fair. I'm pretty open.
Flexible, yeah? So
Yeah,
I'll text you, but for now, provisionally, just keep it that we'll aim for 2 o'clock start, perhaps?
2 o'clock start. Yeah. Okay.
Yeah.
Yeah.
Cool, nice one. All right, Jay. Well, I wish you a lovely evening, and I hope
Cheers,
you take
Andrew.
some time to relax as well. All right.
Thanks. Thanks
Well
for
done.
such.
You're
Cheers.
welcome, Jay. See you
See you
tomorrow.
tomorrow. See you.
Nice and time. Goodbye.